don't know what Dan's doing. Welcome to Cornerstone Home Inspector Education Center. Tonight, we have inspecting crawl spaces in residential homes, best practices, the history of crawl spaces, and hazards. This is a comprehensive guide for home inspectors, and we're going to explore critical aspects of the crawl space, and we'll move on from there. We have our in-person law seminar coming up this Friday at Mohegan Sun. You can see our website for details on that. Okay, let's see what we got here. Did Stan make it back? Yeah, he's back. Okay. Um, this is just our slide. Welcome to Cornerstone Training. Our learning objectives tonight. By the end of this webinar, we're going to master safety protocols, recognize key defects. We're going to learn how to document effectively and communicate findings. Um, the core competencies will ensure that you confidently assess crawl spaces while protecting yourself and providing maximum value to your clients. The first thing we need to know is safety. Learn to identify biological, structural, electrical, and mechanical hazards before entry. We want to take a look at our space before we move in. Defect recognition, understand the difference between cosmetic issues and serious structural and moisture issues. Um, Documentation strategy, master techniques for photography in the dark, confined spaces, and writing sound descriptions. Client communication, develop skills to translate technical findings to actionable recommendation for homeowners. Throughout the session, we're going to provide practical examples, case studies, and hands-on techniques that you can implement immediately for your home inspection business. If you have any questions, you can type them into the chat bot or just break in. Just don't forget to mute yourself after you come in. I think Stan's having a little problem there, but I'm sure he'll work it out. Tonight's agenda, you'll see as we go along tonight that we're going to cover crawl space fundamentals, the types, function, and historical evolution, regional variations in construction methods, industry standards, and historical development from the 20s to the present. We're going to go safety access, the type of tools you should be using, um, identifying key defects. We're going to be talking about moisture, structural issues, how mechanical, electrical, and plumbing concerns to be look for, report writing and client communication. We want to be able to document findings clearly and professionally uh, for liability protection, photo documentation, and best practices of report writing. And then we'll have a wrap up at the end where you can ask any questions. And again, you can just break in as you need. So what we have to do in the state of Connecticut, at least, and what we've decided to do moving forward with these webinars is to go over state standards. And I'm not going to read these completely, but in Connecticut, the inspector shall inspect the structural components of the building, foundations, and framing. The inspector shall probe a representative number of structural components where deterioration is suspected or where clear indication of possible deterioration exists. Probing is not required when probing would damage any finished surface or no deterioration is visible. So in Connecticut, it's a little weird. You go down, you're seeing a sill plate, you don't see any damage. Technically, you don't have to probe it. I personally probe it because the termite damage and water damage can be, with inside the wood and you can't see it. It could be from the other side, from the outside. The inspector shall describe the foundation and report methods used to inspect underfloor crawl spaces or basement area. You must describe the floor structure, the wall structure, the ceiling structure, and the roof structure, and report on methods used to inspect the attic. The inspector is not required to provide any engineering service or provide architectural services. Rhode Island, New Jersey, Massachusetts all have pretty much the same. You have to observe and report on the foundation, floor structures, wall structures, that kind of stuff. Um, Again, Massachusetts is a little bit more in depth, and you should go to your local SOPs to read them over always. And then, one of the things is that's a good practice is to at least once a year, I read the standards of practice. I just go over them again and again. I print out the current ones if they've been updated, and I highlight what I'm required to have in the report. I highlight any important information that I think is going to affect the inspection. So, so what is a crawl space? The definition is an unfinished accessible area below the first floor with limited clearance, typically 1 to 3 feet high. Unlike basements, crawl spaces are not designed as living spaces and have minimal headroom. Access is usually entered through small hatches in floors, closets, or exterior foundation walls. The access points are often 18 by 24 or larger to allow inspector entry while maintaining structural integrity. The purpose is to provide space for utilities, creates a buffer between the ground and living spaces, and offers easier access than full basements. Helps protect floor systems from ground moisture and creates air circulation beneath the structure. Typically built with concrete, masonry, or treated wood foundation walls surrounded by dirt, gravel, or concrete floor. May include support columns, beams, and foundation walls. Um, the components may contain vapor barriers, insulation, ventilation openings, plumbing lines, ductwork. You can find electrical, mechanical systems like water heaters or other HVAC units down there. Um, Variations range from sealed modern designs with conditioned air or traditional vented styles. Height and accessibility vary significantly depending upon the home's age, region, and building practices. We're going to go through all these, and you're going to see samples of them as we move forward through the webinar. Key functions of a crawl space. Uh, Crawl spaces serve several critical purposes in residential construction, providing both structural benefits and practical advantages for homeowners and maintenance professionals. Utility routing. Who we got? We got any questions? Okay. Um, uh, the crawl spaces will house plumbing, electrical, HVAC systems for easy access. This accessibility allows for repairs and inspections without disturbing living spaces or requiring extensive demolition. Updates to home systems can be implemented more affordably when workers can readily access the connection points. And I can tell you from experience, some of these heating systems you can come into and they are at the other end of a crawl space 200 feet down, and it is not fun getting there. And we're going to go talk about accessibility when we start. I see Stan, you've joined us. Are you all set?
Yes, finally.
You're here. Okay. And then climate buffer. The crawl space insulate the floor from the ground temperature extremes. This airspace provides natural thermal regulation, reducing energy costs both in summer and winter. Modern sealed crawl spaces can further improve energy efficiency when properly designed and maintained. They also act as a ground moisture barrier, which creates separation between damp soil and the home's structure. This crucial buffer helps prevent wood rot, deterioration of support systems, and reduces the risk of mold growth in living areas above. Proper vapor barriers enhance this protective function. Elevation solution. It adapts homes to slope lots and various terrains. This design approach eliminates the need for extensive grading or fill, reducing construction costs while providing solid structural supports. Crawl spaces also offer protection against flooding in low-lying areas. So tonight, what we're going to do is we're going to go back and forth between Stan and I, and Stan's going to take over right now.
So, spending my entire career here in Connecticut, I've seen, and I think Scott could speak to this as well, especially on the coastline here. We've been in a lot of crawl spaces, beach cottages. Some are in really good shape, some are in really bad shape. But it might only be 10% of the houses we do. I don't have an exact percentage, but my son lives in North Carolina. When the first time I went to visit him, he drove us all around, and they are predominantly crawl space. So when you inspect in North Carolina, parts of South Carolina, probably other states out there, you're spending a lot of time in crawl spaces. So this little device here, or those like them, are probably essential out there for a lot of guys. Um, I'm sure they all don't have good, size and accessibility. So when you can't walk away from 75% of your house is saying, well, I can't see underneath there. So I guess they're using these guys. So can they actually access all areas of crawl space? What I'm seeing on Facebook home inspection groups is no. So they still have some inaccessibility. The cost, they range from $100, you can throw that one away, up to $5,000. So are they cost effective? Is that something you would want to spend? I guess if you were getting in a lot of crawl spaces, yes. Oh, here, I'm going to say that I wouldn't spend any kind of money on a crawl box. And are they reliable? They do break down. Just like drones crash. You lose drones, you can lose these guys in the crawl space as well. But it is a tool that's becoming very popular in areas that have a lot of crawl spaces. And I'm going to say in 37 years, I've probably was unable to get in about a dozen crawl spaces. Most of them I'll belly crawl through, I'll get in them, I'll check them out. Of course, if they're dry and I see one piece of asbestos insulation laying on a crawl space, I am turning around and hightailing it out of there. Okay, Jim. So common crawl space configuration. So the vented crawl space, which is what I saw first half of my career. Most of them were vented in my opinion, vain attempt to keep the crawl space dry. I don't think a lot of airflow goes through those vents. And then in the summertime when it's very hot and humid outside, if any of that humid air gets in the crawl space, it's going to condense and add to any problems that are in there. Traditional design with foundation vents allowing outside air circulation for moisture control and radon mitigation. Common in older homes built before 1990. I'll attest to that. Prone to seasonal moisture issues, especially in humid climates. Typically has exposed soil floor, sometimes with partial vapor barriers. So what I used to see was some plastic just laying on the floor, didn't cover everything. Very wet underneath a lot of times. It requires proper cross ventilation with vents on opposing walls, but they didn't always work either. Susceptible to energy loss and pest entry. Definitely pest entry, energy loss if you don't insulate the floor, or if you can't keep the insulation up in the floor. You're letting the cold air in. Real quick story, my father-in-law, God rest his soul, he had a condo here in Milford, and when he bought it, I inspected, and they had a moisture issue that we brought to their attention. And I guess it continued on. It was a vented crawl space. They had insulation in the floors that was getting wet and flowing out, so they took it all out. And I would go over the house there, and he'd be sitting with a blanket on, and he'd be freezing, and he'd have a space heater next to him. So I went in the crawl space, I bought some foam, and I closed those vents up. And he said, oh, they're going to get mad. And I said, let them get mad. You're not going to sit here and freeze. And then in the spring, I popped him out, and he was fine. So there's definitely a energy effect if there's no insulation and you have a vented crawl space. So unvented crawl space. Closed system without exterior air exchange, designed to reduce moisture fluctuations and improve energy efficiency. They became popular in the 90s as building science evolved. May have insulated walls rather than floor joists. Usually includes vapor barrier, but may not be fully sealed. Creates a semi-conditioned space beneath the home. Can reduce utility costs by 15 to 18% when properly designed. And inspection focus, insulation integrity, partial moisture barriers, and foundation wall condition. Scott, when we and Jim, when we went to Larry Janeski's for his energy efficiency, wasn't that like the end of the 90s, maybe early 2000s when he jumped into this? So he was the first person to present to us the sealed crawl space. And he was preaching that you didn't need to vent any crawl space and it should be sealed. Now, at the time, I thought that was his theory, but maybe it was somebody else's that he just started working with. But so I see these. I'm sure we all see these periodically. Not as much as you would think. It's a joy to work in when there's that much space in there, nice and clean, and then encapsulated, which is almost the same, right? Completely sealed system with comprehensive moisture control and integration with homes conditioned space. Modern preferred approach in most climate zones includes fully sealed 10 to 20 mil vapor barrier on all surfaces, often has dedicated dehumidification or conditioning equipment, significantly reduces moisture, allergens, and pest issues, provides improved air quality and energy performance, and may include monitoring systems for humidity levels. When you're inspecting it, you're making sure there's a barrier integrity is not degraded, the dehumidifier function, if there is one, and sealed penetrations. So they usually do come with some kind of sophisticated dehumidification system. They always need to be serviced. I don't think the homeowner is going to go in there and check to see if things are working properly. So when I do run across these, several of the companies in our area will put a sleeve on there with their paperwork in there and when it's supposed to be inspected, service next. And very rarely will I see that service documentation up to date. So I will at least put into my report and make sure that the prospective buyers know that that's a system just like the heating system and the hot water system and the electrical system that needs to be periodically maintained. Okay, Jim.
Stan.
Yes.
Can you just go over, and I know it's part of it's part of our standards, and we'll actually probably discuss this coming up this week. And we've had this discussion many times. Can you talk a little bit about what your definition or your of readily accessible crawl space, and some of the crawl spaces that we've discussed and have throughout the years where they were sealed off, you know, and some with screws, some of the panels that you couldn't get open, some you could. What's your thoughts on all?
Sure. So I own a screwdriver. I own several. And if there's 4 screws holding a piece of wood in an access to the crawl space, I will remove those screws. So the crawl space is not inaccessible to me just because there's a screwed on piece of wood preventing you from going in. If I can't fit in that space is another thing, then I would have to say that it would be inaccessible for me. But I know a lot of guys, if that's cover screwed on, they're not going to go in. If it's locked, they're not going to try it with the lock. They're not going to try and find a key. But I will try to get into as many spaces as I can because it's pretty critical. Because you know your structure is in there, your ability to look at the structure, moisture potential, all that stuff we really need to be able to see. So I will take the cover off, especially they're usually screwed on pretty good if there's a crawl space attached to a basement, which should be open in my opinion to balance with the basement. So I do attempt to get in all of those. If the screws are stripped or I can't get them out, then I can't get them out, and I write that up in the report. I know a common theme going forward when we talk about home inspections is documenting the things that you can't see and can't do, and I think that's very important. So I will do the best I can to get into spaces that are sealed up like that. Size-wise, now I'm a little bigger than Scott and Jim. I used to be much bigger than Scott and Jim. Well, once I get inside there, sometimes you know how the terrain goes. You can only get so far. Then you have to document as far as you got. And with the camera, I think it's kind of easy now to take pictures and show when the grading gets really high or a pipe is going across it, you can't get by. But all that stuff has to be documented. And the standards are kind of, if anybody's attending on Friday, we're going to go through all this. They're kind of left to interpretation. They tell you what you have to do, have to record, and what you don't have to do. But then the rest is left up to each one of us. It's how far we want to go.
I'm just going to break in here for a minute. You're going to take over the webinar because I guess I'm causing the feedback tonight. So
Okay.
I'm going to mute myself, and you and Scott can continue on. Okay.
Okay.
All right.
All right. So if you are viewing this as a recorded webinar, you will need to send this viewing code CP4647 with another one later on in this presentation. And you submit it to our website and you will get your certificate. So construction timeline, 1920s to 2020s. 1920s to 1940s, pier and beam with open dirt crawl spaces, minimal moisture control. I can attest to that, and I'm sure that anybody that's been in a cottage on the shoreline, a lot of times you would see cedar posts or maybe the old style concrete blocks, strategically located. Over time, there's still a couple in Milford where you can, if you got on your belly, you can roll from one side underneath that whole house to go out the other. That's the way they were constructed. Later, some walls were built, whether they were block or wood, to fill in the gaps between those posts. And then sometimes there were full block foundations, but still on a crawl space. So 1950s to the 70s, vented crawl spaces became standard. Introduction of basic vapor barriers. And then 1980s to 1990s, increased insulation requirements. First attempts at crawl space conditioning. And then from 2000 on, sealed conditioned spaces gained popularity. Advanced moisture management systems. So I had a thought there. Vented crawl space against vapor barriers. If you think about it, when those spaces were open, nothing was underneath there, so all the mechanical systems were upstairs. When those perimeters were closed in over time, these houses, at least in our area here, were built for seasonal use only. All the shoreline cottages in Milford were vacation homes. If they had heat, they had a Coleman heater in the middle of the house. Over time, when it became more desirable to live down near the shoreline, they were developed to different levels. And then we had central heating. We started to see crawl spaces get dug out to put the mechanical systems to give them more space upstairs. So every version of that, I think you can see up and down the shoreline here, and there are crawl spaces inland as well. I don't think they're as plentiful though. Okay, Jim. So here's kind of maybe not with those footings, but this is kind of typical of what we see around here. You have your posts on; those are nice bases. Sometimes we just see stones or plops of concrete on the grading and sagging all over the place. If you on a dirt floor, it looks pretty dry there. So you really, just because there's no vapor barrier doesn't mean that there isn't a moisture problem, but that looks fairly dry. And it looks like you could probably get through that crawl space fairly well. You know, the spacing is, the cottage style crawl spaces were cottage framing, 24 to 32 inches on center for the floor. There's no floor joists there. It was all beam and, oh yeah, they're on an angle. You can't see them, right? So, but that's pretty typical. And then here we have 2000 to present. Space to move around in there, in my opinion. But like I said, very welcoming crawl space, clean. Probably have to look hard for insects when the insulation and the vapor barrier is up, but so you spend a little more time looking for termites and such. Okay, Jim. So used by region. So the Northeast, 30%, Southwest, 15%, Midwest, 25%, and then Northwest and Southeast, they go pretty high. So those guys are spending, those inspectors out there are spending a lot of time in crawl spaces. The Southwest, Southeast, and the Northwest show the highest crawl space prevalence. Their humid or damp climates often necessitate elevated homes to mitigate homes' moisture and flood risk, requiring vigilant inspection for moisture intrusion, pest, and ventilation. Conversely, the Midwest and the Northeast utilize fewer crawl spaces, favoring slab on grade or full basements due to colder climates and frost lines. Okay, Jim. So foundation type comparison. We're looking at 4 categories here, right? Feature, crawl space, slab on grade, and basement. So for utility access, crawl space is, well, I would say modern crawl space is excellent. Slab on grade, not good, right? You either have to put your plumbing in the slab or run it through areas that you prepare on the frame of the house. Basement's excellent. Excellent. I don't know if I would say a crawl space is excellent. I'd say basement is, because you can stand up in there and service everything, but they rate both as excellent. Construction cost, crawl space is moderate. Slab on grade is the lowest cost. Basement is the highest. Moisture concerns, crawl space is high. Moisture, slab on grade moderate, and basement high. And inspection difficulty. So moderate, and crawl space, depending on when it was built and what kind of space you got to navigate. And slab on grade is low because all you probably see is the edge of the slab. And then the basement is low, right? Because if it's unfinished, you see everything from the inside and part of it from the outside. Okay, Jim. Modern sealed crawl spaces. Sealed crawl spaces represent the latest evolution in foundation design, offering a controlled environment beneath the home that solves many traditional crawl space problems. The approach has gained popularity as building science has advanced, but requires careful consideration of both benefits and potential drawbacks. So complete sealing. Properly sealed system maintains humidity levels below 55%, preventing condensation and associated problems. Studies show up to 80% reduction in relative humidity compared to vented spaces. Energy efficiency improvements. You know, if we control that crawl space air and humidity, then it's going to make the air in the house, air quality in the house, much better. Reduced heat loss in winter and cooling loss in summer by eliminating the exchange of air, conditioned air with outdoor air. Can decrease energy costs by 15 to 20% in some climate zones. Structural protection protects floor joists, subflooring, and other wooden components from moisture damage, potentially doubling their function and lifespan. Number 4, required maintenance. Dehumidifiers need regular filter cleaning. Condensate pumps must be monitored, and moisture monitoring systems require periodic checking. Annual professional inspections are recommended. So the people who actually put those together should be the ones servicing them and maintaining them. Vapor barriers, potential failure points. Vapor barriers can become damaged from service work or pests, compromising the entire system if not properly repaired. Even small breaches can significantly reduce the effectiveness. So if it's a space that's used a lot, it's much more critical to get in there and take a look around. If these people that own the house don't go in there at all, you still need to be aware of it, but it is probably less likely to be damaged. And And number 6, inspection considerations. Require inspectors to understand integrated systems rather than simply looking for obvious defects. Evaluation includes checking barrier integrity, mechanical system operation, and moisture equipment. So there's something here that's not mentioned. If most of the wood is covered by vapor barrier, then we can't do an effective wood destroying insect inspection. I say we because I do my own. But even if you hire somebody and bring them along, they're not going to see too much of that wood. And how do we know what's going on behind all that barrier? I mean, we could have decay. So you have to state that, just like a finished basement. You have to make sure that you put in your report that the actual wood framing was concealed by a vapor barrier installation. If you can see any of it, you inspect it, but you really got to document all that. So case study, 1950s homes, poor initial design, vents placed too low, allowing surface water entry during rain events. That only happens when the crawl space is not that high. Then that a lot of times the access to some of these crawl spaces I've been in is right at grade level. So then you got to look around at that side of the house or wherever there's an entry point and see how that water looks like it's going to flow. Crawl space had 6 foundation vents positioned only 4 inches above grade, creating direct water paths during even moderate rainfall. Code now requires minimum 6 inches clearance. That's a lot more, huh? Inadequate grading, negative slope directed water towards the foundation rather than away. Original landscaping sloped approximately 1 inch downward for every 5 feet towards the house foundation. So I tell people, whether it's a basement, a slab, or a crawl space, that grading is critical no matter what kind of house you have. All right, we don't want water in the basement. We don't want water in the crawl space. I don't even want the slab to get damp and wet. That will transfer to the house. So that's in every inspection that I do. Missing vapor barrier. I still see these crawl spaces with none, and maybe very little, if no, insulation in the floor joist base or joist beam. So original construction had no soil cover, leading to 70 years of moisture exposure. Without a vapor barrier, soil moisture continuously evaporates into the crawl space at an estimated rate of 10 to 20 gallons per day, causing relative humidity to remain consistently above 80% year round. I'm sure that can happen, you know, but that's not on a regular basis, at least in my experience, because I can pick in some of these crawl spaces, I'll pick up the soil and it's almost like sand. It's so dry, dripping through my hand. Resulting damage. So extensive joist rot requiring 18,000 in structural repairs that could have been prevented. Inspection reveals that 60% of floors that floor joists showed moderate to severe decay, particularly at beam pockets and along the perimeter. So this is a case study, don't forget. 3 primary support beams required complete replacement due to extensive fungi growth and structural compromise. So you will see that occasionally where the house really needs a lot of work structurally. And that's why you need to be able to get in there. Now, if you can't get in there and you walk around the house heavy-footed, you may be able to feel some more flex, more bounce than you thought. That doesn't really help in evaluating what's going on underneath, but I would put that in the report to make sure that these folks know you couldn't get in there and it doesn't feel good as I walk through the house. So structural elements. Comprehensive inspection requires thorough understanding of these critical crawl space elements. Primary load-bearing components that support the home. Very similar to a foundation, just on a shorter level. So you're going to have a carry beam, girder, whatever you want to call it, and floor joists extending from them to the foundation walls. Those beams or beam, depending on how the house is built, will need to be supported by piers and columns. You may see steel occasionally, maybe from a rehab. Typically, what we'll see is a wood or concrete block column. Foundation walls along the perimeter of the structure, girders and rim joists, horizontal framing, footings, base supports for the pier walls, and sill plates where framing meets the foundation. Just like a home, just like a basement. Moisture control systems designed to maintain and manage humidity and prevent water intrusion. So again, vapor barriers, ventilation systems, drainage solutions, which could be sump pumps, perimeter drains, dehumidifiers in sealed systems, gutters and downspouts, right? Exterior water management, runoff management, and grading and landscape. Always, no matter what kind of house you're doing, those things got to be really looked at. Essential home systems that often run through the crawl space, so plumbing lines, electrical wiring, junction boxes, cables. In the older houses, they were run with BX, and they could get very rusty. HVAC ducts, same thing. Gas lines, water heaters. Probably in more modern crawl spaces, you'll see the heating systems and water heaters, sump pumps systems for water removal, and then insulation. In a sealed crawl space, sorry about that. In a sealed crawl space, we're not going to see the insulation, but if you have a chance to see it, you will identify it, make sure it's in good condition, make sure it's in all the places it's supposed to be. Are the ducts insulated? Can you see the rim joists? Are they insulated? And then, you know, if there's vapor barriers in place, are they in good condition? So what type is this? I guess clue number one, it's vented. Note the foundation vents, but also the sealed portions. This is a hybrid approach often seen in partial renovations. Clue number two, moisture control. So they do have a loose fitting vapor barrier on the floor, probably over a dirt floor. So an upgrade from a traditional vented design. Clue number three, the insulation. It is up there, it's exposed. It's probably got those little metal rods holding it in place. And then conclusion, this is a transitional crawl space, originally built as vented, but with attempted upgrades toward encapsulation. So this is what we see on the shoreline here as it evolves. Somebody comes in, buys a house, they add this, they add that, they try and get some insulation in there. Eventually somebody comes in and just guts the whole thing and starts all over.
I'm breaking in because we have a question. How do you write up common support piers seen in an antique home? Just a pile of rocks or a dirt floor, but hasn't moved in 100 years. Fix it to modern, or is it fine? So I can sort of jump in on this. I've run into this a couple of times, and when I first started in home inspection, I used to call it out that there was no footing, that a piece of wood or a jack stud or a log was just sitting on the ground. And I used to call it out all the time. And then an engineer called me up. It actually twice happened. I had an engineer meet me at the house one time. And this was many, many, many years ago, and explained to me that there's no freeze or thaw underneath the house, that the support beam or lolly column or log or piece of wood needs something under it. It can't just, you don't want it sitting on dirt, but it could be a concrete block or paver. It doesn't necessarily have to be 48 inches into the ground. What you can, we're going to get into report writing. We have 20 minutes left. We're going to run through this, but during this webinar, we're going to get into report writing and how to write these things up. But personally, I just write to see, when I write up my reports on something like that, is I will put in the comment that this is not unusual for an antique home, that the support was solid, there was no movement of support. I'll write any decay or anything like that. I will put if nothing's underneath it. and that upgrades may be needed. So I don't know I'm going to mute myself, but I don't want to cause any feedback. But I don't know what your thoughts are, Stan.
You're not feeding back now, but so
Oh,
um, that is a very good question and something that I kind of grappled with early on when I first started doing this, because I think one of the problems is I see a lot of things going on now with new inspectors that I went through when I first started, and it was totally different back then because I had to go out and find all this stuff. There was no training available like it is today. And then I started realizing that, and that by the book doesn't always happen, especially when the book wasn't even written. Some of these buildings were built, there was no book. So I kind of look and see if there's anything that looks like it's in distress right now. If I don't think the structure is there, that there's integrity with the current formation, I would always tell them that there's better ways to support this, and at some point they should consider it. Again, if I see that there's a major sag in the kitchen and that's right above the column, then we have a problem. So
all right.
I kind of go case by case. And don't forget, a two-story building, which we have here over at Crawlspace, has much more weight on it than a ranch style, a one floor.
Right.
So you got to
So
take a
it's
lot of things into consideration.
something that should be called out for evaluation, but not necessarily as an emergency. If you have a 300-year-old house, it is sort of what it is.
Look, when you're in doubt, be a quarterback.
Ball.
Hand the ball off to somebody else. You know, you did your job. You found a potential issue. Let somebody else come in and give them how to fix it. So, Jim, we're a
Absolutely.
little bit behind here. 20 or
Yeah, so we got
57.
so why don't I go through a couple of these?
Okay.
Safety first, crawl space. If I start getting feedback, just tell me. Crawl space hazards, life-threatening hazards, gas leaks. You want to look for exposed electrical, any collapsing structures. You want to look for any health hazards, mold, asbestos, rodent droppings. Obviously, we're not looking for radon. Ridge, physical injury risk, sharp objects, low clearance, unstable surfaces, snakes, rodents, insects. When you go in there, get your flashlight out if it's not lit, and you got to check. I can't tell you how many nails are sticking out of the decking, and you lift your head up a little bit, and that's it. It becomes a bad day. So just be careful when you're in these crawl spaces. We want to make sure personal protection checklist, head protection, respiratory protection, bring a mask because it could be dusty down there. Body coverage, you should have something that if, I personally go into a basement or crawl space last because I don't want to track everything through the house and I want to see if there's been any leaking from water running. But disposable coveralls are good. Knee and hand protection, hot resistance gloves, knee pads. I wear glasses, so that's not an issue, but safety glasses to prevent injury from debris, insulation fibers, and dust. Common stuff. Again, biological hazards, mold and fungus, rodent contamination, and insects. We're looking for all this down there. Structural hazards. These conditions represent immediate safety concerns. Stop your inspection and notify the client if you observe any of these critical structural failures. So when we go in there, we see loose supports, we see rotted beams, and extreme sagging. That might not be an area that we want to be in at that time, and just to call it out. Electrical and mechanical risks. We're going to be looking for exposed live wiring, open junction boxes, damaged wire insulation, as Stan talked about, improper splicing. We see this all the time. Water in contact with circuits, missing GFI protection. Again, gas leaks, sharp metal ductwork, hot water lines, unprotected fan blades, low-hanging pipes, and any kind of abandoned equipment. Tools of the trade. We want to make sure we have good lighting, cameras, moisture meters, possibly an infrared camera. Testing tools are probe, screwdriver, electrical tester, and tape measure. And I have a humidity gauge with me now, so that's one of the things I test for. Infrared tools when they're used. I'm not a big, not that I'm not a big believer in it. I don't use infrared. It can cause a lot of issues. Stan, I don't know where you stand on that. Do you want to comment on that?
I don't have one.
Okay.
I don't use it.
So, if you have, yeah,
I'll-
go ahead.
And I went through the certification. I'll tell you, if you see an anomaly, just say you're looking up a second floor bathroom, you see a water stain on the ceiling, right? Usually we go, hey, it's either from the sink, toilet, or shower tub. So you put your camera up there, you see an anomaly, you see a area where you suspect water's leaking. You know what you gotta confirm it with? A moisture meter.
Right.
So if you do see something, you're supposed to confirm it with a moisture meter. So, it's nice to have, and it's something that I think some guys use, and some guys use a lot more. But my personal opinion is, I mean, it's another service. Some people will say, hey, do you have one of those? But if you're going to do it, charge for it. I think we have a lot of stuff that we add with our inspection. We don't charge for it. It has a purpose. If you're going to do an energy, if somebody asks you, hey, I got an older house, can you see if there's any insulation? And what do you think? And you can look from the inside or the outside. I'm hearing a little feedback on your end.
Okay. So why don't you?
The answer is it just depends on the inspector. If I still see a stain, to me, if there's a stain up there and it looks like it's been patched and painted and it's stained again, there's a problem. Or if it's patched, or if there's a stain, unless somebody can say, hey, we did some repairs, I put it in a report and have somebody look at it, and try to, or at least find out what was leaking. But I do, to me, using it, I'm still calling it out either way,
Okay. So we're gonna move along here, and entry points and access standards. The minimum requirement is 18 by 24. Best practice is 24 by 30. Interior clearance, we want 18 inches from soil to joist, 2 feet for proper inspection. Access location, 1 entry point, multiple access points for larger spaces. Lighting, there's none required by code. Permanent lighting on a switch would be an ideal. When the space is inaccessible, we got to document that limitation. You should take clear photos and show why it was restricted. Measure and record what's going on, exact clearances, access points, and dimensions. So, hey, listen, I couldn't get into it. Well, the access was 6 inches by 6 inches, and you got to have proof for that. And again, if you could use cameras, remote poles, or crawlers when possible. And report language, use specific disclaimers for inaccessible areas. You need to clearly state why you could not get in there. And I really quickly, because we're going to be low on time here, I had a situation where I went into a house, Basement Systems in Connecticut went in there. It was a really old house. They had plastic that whole basement. You could fry an egg. You could do an operation in that crawl space. It was so clean. It was ridiculous. So I went in there, took a few pictures. You couldn't see anything but plastic. I said, it's really inaccessible. I can come in here. I'm taking pictures. I don't see any moisture intrusion. I noted everything. I get a call 5 years later from the client, and she's really upset. She's selling the house. She had hired me to do her next inspection, but the next inspector came in to inspect her house, rips out a bunch of the insulation and finds some termite damage. Why they would rip out a probably $25,000 job that Basement Systems did, I have no idea. But they did not put anything back the way they were supposed to. And that caused issues. But I was fine with it because I had everything in the report stating the limitation of inspection, why I could not inspect the joist, why I could not inspect the main girder. It was all there. And, what are you going to do? But complete documentation is really important.
How many years later, Jim?
It's five or 6 years later.
Who knows if it came afterwards? I mean, 5. Yeah.
Yeah, but the point is, you're not punching holes in sheetrock to see if there's termites. Why are you ripping off a seal, the insulation and vapor barrier on a sealed crawl space or basement?
Right.
Was it
you know,
regular insulation? He might have just moved it, or was it spray foam?
No, it was, Jim said it was sealed.
it
So,
was sealed. You know, it was the plastic
Should've done
material
that.
that they glued, and the next inspector went in and ripped it down because
Not
he
good.
wanted to see what was going on there, and that was ridiculous.
yeah, you don't do that. So that's
Of course you don't. Inspecting in tight crawl spaces, you know, have a plan. You know, plan your path of where you're going to go, what you're going to bring down there. I know even going through some attic spaces, I take off, my flashlight belt and all that stuff because, I got to get into that space. And you should always have a communication device on you. So if you're inspecting alone or something like that, and the agent's not there or the client's not there, just in case you get in trouble, you got somebody to call. So common crawl space defect overview, moisture issues, standing water, condensation, water intrusion. That's about 45% of what's going on in today's crawl spaces. Structural problems, which is sagging beams, cracked piers, shifting footings, and compromised support systems is about 18%. Insulation and vapor barriers, missing or damaged barriers, fallen or compressed insulation. I see this all the time, but generally it's around 15%. Pest damage is about 12%, and utility issues, damaged ductwork. I can't tell you how many times I go down there, and at the end of the crawl space, the ductwork's collapsed, and the kitchen's not getting heat or air conditioning. So that happens. Stan, I'm going to have you take over.
Yep.
There you go.
I think we beat moisture to death already.
To death.
No.
Yeah, I agree. So let's go through that, and then here's a sample.
I mean, that's not an exaggeration, but that moisture is on top of plastic. Am I seeing that right?
Yep.
So that's an interesting problem right there.
That's a missing subplot.
But it's not uncommon to get into a crawl space or even to look in a crawl space and see standing water.
Sometimes it's not just surface groundwater. It can also be plumbing. Yeah.
Yep.
So your viewing code, your second viewing code is CP6695, and you'll be directed to supply these codes if you're watching this as a recorded event. Are you good, Stan?
Yep. So this is kind of like basement, right? When you see the efflorescence on the foundation wall, it doesn't tell you exactly what's going on, but it certainly tells you that wall's being saturated with moisture, right? If that's the least of it, that's one thing. But generally, if you look around at any wood that's touching the ground, you see water stains, or there's probably more to it than that. But that's enough for me to say that there's evidence of dampness and or seepage in the basement. And then if I can parlay that with other things that I've seen, say outside, grading and roof drainage and stuff like that, then you could make a more definitive call. But it's kind of the signature of dampness in the basement, and water passing through. That's the cause. The water's passing through the concrete, and when it dries, all the salts and minerals that it brought with it is left on the concrete. I think we will. I hate mold because we used to say mold without even thinking twice about it, and then all of a sudden, somebody got sued for calling something mold that was not mold, and we have to say a organic growth or a discoloration that may be mold. But I think we all know what we're looking for and how to protect ourselves with that, just like any other house, basement or even in the house. But that's what you want to look for, and that comes along with the moisture. And moistures in plumbing areas, foundation walls, and HVAC components could generate condensation and moisture as well. Okay, Jim. Rusted fasteners, rotting wood, probably more prone in a crawl space than a basement. But that that's why you got to get in there to look around, probe, see what you got, how bad it is.
Sure.
And document no matter what type of foundation or configuration, the extent and locations of the damage, the structural elements affected, the moisture source, if identifiable, and the severity of the assessment, cosmetic versus structural. You could stick your screwdriver in there a couple inches, you got a problem. If it's
Exactly.
compressed, you got a problem. Okay, Jim.
All right.
So damage and missing vapor barriers. There is a minimal thickness that you should be using at 6 mil. 100% coverage. The wall extension. So we kind of do, well, I don't do it anymore. Scott, kind of similar to the radon, right? When you're sealing a crawl space, same thing.
Yep.
So you go up the wall 6 to 12 inches, you seal it. 70% failure rate. Well, I have no way to speak to that, but that's what you're looking for. And then floor joist insulation, right?
Yeah.
Is it visible? Is it being held in properly? When it gets damp, it'll start to fall out. When you see it all on the ground, or if you have rodents. But you call it out when it's in disarray, missing. You call it out. Again, moisture damage, right, is also a reason why the insulation, and then pest infestation.
Right. A lot of times you go into the attic, into the crawl space, and you'll see the insulation with the paper on one side. It's the incorrect way. That paper is grabbing moisture from the from the crawl space and the humidity. A lot of times that just stuff needs to be ripped out and either replaced. All right, inspecting pest damage. We're going to look for termites, carpenter ants, powder post beetles we see all the time, and rodents. Visual indicators on termites are mud tubes, frass, swarm evidence, hollow wood following the grain, and wood to soil contact points. Carpenter ants are sawdust piles and live ants. Powder post beetles are the tiny little holes, and it will leave fine powder on the floor underneath it. A network of tunnels and brittle wood. And rodents are kind of obvious. So we're short on time here. Structural shifts, cracked pier, sagging beams. We're going to check structural points, examine the pier to beam connections for proper bearing and alignment. You want to make sure everything's nice and straight. Excess levelness. You want to know any deflection in the floor or your beams. And you want to evaluate as much of the material. Check for concrete deterioration, wood rot. We've been through this in this webinar. Failures often begin with the moisture exposure. So, and a lot of times an initial installation where they just didn't do it correctly. But in these older crawl spaces and these older homes, these sagging beams you'll go into a crawl space and you'll see logs with tremendous termite damage and powder post beetle damage. And I've seen no modern 2x6, 2x8, nothing, sistering it. I just call it out all the time. I just call it out for examination of the framing as a whole. Even though the house has been there for a couple hundred years, it's good to protect yourself. HVAC issues, we've talked about disconnected ductworks. You can get mold growth. You want to check for damaged sections, missing insulation, and improper support. Sagging ducts create low points where the moisture will collect. We're going to look for plumbing issues, leaks and condensation. Of course, we're going to look for active leaks, past water damage, condensation problems, and improper installation. Sagging, improper pitches to pipes, all that stuff is going to be in there, and all should be documented. We've covered electrical issues, open junction boxes, moisture in contact with electrical. I always see extension cords in there because there's usually no light down there, so they'll run an extension cord from someplace. Unsupported wiring. Again, the open junction boxes, the rodents will eat through these wires, and knob and tube wiring. It's going to be in a lot of these crawl spaces, especially if they're older. And missing and damaged conduit. We want to look for any kind of electrical issues. It's very important. And a lot of times in a crawl space, it's just going to look like this because the electricians don't want to get in there and properly support everything and make it nice and neat. Inadequate support systems, we've talked about this. You're going to go in, you're going to check for your spacing, verify alignment, check for any loose posts, any loose logs, any disconnections, improper materials. That all should be supported properly and pointed out in the report. We're going to look for ventilation problems. We're going to look for blocked vents, insufficient quantity of vents. We've talked about this. Poor placement. They're too low. Closed vents during the summer humidity, or open vents during freezing and weather. We have to check to see what they are and how they should be open during different seasonal times of the year. Again, we're going to have common defect photo guide. We want to have everything in the report and photographic evidence of it, of the termite activity, any kind of plumbing failures, and foundation compromise. Horizontal cracking, very important to point out. So we're going to get into a little bit of report writing. We've got about 5 minutes left. What should always be reported on? Safety hazards, structural issues, water and moisture, and infestation. We've covered all this. How to disclaim inaccessible areas. We want to document, be specific, and recommend what the next steps are. Stan went over this on how to get into a place. Crawlspace report language. This is some of the, we're going to be adding more of these to our webinars at the end of the webinars on actually what we should be writing, moisture issues, the appropriate report language. Standing water was observed in the east portion of the crawl space. This condition can lead to structural damage, mold growth, and pest attraction. Recommend evaluation by a drainage specialist. Structural concern, and then I'm not going to read all these because we're low on time here, but you're going to put a limited access. Approximately 40% of the crawl space was inaccessible due to low clearance or clearance issues below 18 inches. So we want to have good report language. And this is something that put in my reports, and I've been seeing more and more of, is observation. Evidence of water intrusion was noted within the crawl space area. Signs included damp soil, standing water, and or standing water staining on the foundation walls and support components. The intrusion may occur during heavy rain or periods of high groundwater. It's not, that's a great comment. It could probably be longer depending upon what you're seeing. And then most people just skip to recommendation. But I've been adding more and more to my reports an implication, telling people why this is bad, because I've been getting calls like, hey, you noted this issue. Why is that important? Chronic moisture in the crawl space can lead to structural deterioration of wood framing members, microbial and mold growth, pest activity, and reduced indoor air quality. It can also contribute to high humidity levels throughout the home, potentially impacting insulation and floor systems above. So we have an observation, an implication, the recommendation, and then the limitation. What this does for you is that you're telling what the issue is, how it affects the home. You have your recommendation, which for licensed contractor for the appropriate system, and then the limitation why you couldn't get someplace or inspect a certain area. This section here has been helping my agents out a lot too. Not that we care what they do, but a lot of agents are not knowing what's going on, and they can, in their negotiations, can go to the seller and say, this is why this is a problem. So this kind of setup in your report can help.
Agreed.
When to recommend further evaluation. Again, active water intrusion, termite, hazardous conditions, significant mold growth. And you want to use your photos to tell the story. Comparative imaging, what's good, what's bad. Put your little annotations in there if your software allows to point out the problem. And sometimes you need to show scale. Taking a picture of a crawl space and it's 100 feet down, maybe they don't get the idea of what's going on and how big the situation is there or how deep it goes. Legal risk reduction. Wording matters. You don't want to say perfectly safe, guaranteed dry, code compliant, will last for years. What you want to say is no safety concerns observed, dry at the time of inspection, evaluation for code compliance. I'm not a big fan of that. Appears to be functional, further evaluation recommended, considering monitoring this condition. So your wording really does matter. And as a final documentation checklist, we want comprehensive photos, orientation references, measurements, access documentation again, and condition summaries. So all this needs to be in the report and clearly put out there. And again, to wrap up, safety first, thorough documentation, clear communication, and continuous learning. So we made it. Stan, do you have anything to add?
No, I think just use your head, use common sense. If you've been in this business for any length of time, and you're still in it, then you're doing something right. So just keep on documentation and head on a swivel, basically.
Yeah. The crawl space could be an extremely challenging place to go. You've had a busy week. It's a Friday. You got that old house. You're bent over. You're on your knees. You're sweating. The summers can be a pain, and we've all been there. You're not having a great day, and to get around that crawl space can be really, really, really an issue. So having these, I mean, I know I carry full body protection with me. I don't use it all the time, but the knee pads I do use as I get older, and I have always a good set of gloves with me. um, and that's been a big help. But it can be challenging with your camera if you're writing a report on an iPad to take pictures. They're dusty places, and you come out of there, and it can be really, really challenging. But the idea is to be as careful and well prepared before you go into that space. Cool. Anything else by anybody? Any other questions? I think we'll wrap it up tonight. Thank you for coming. And
Okay,
then,
everybody. Thank you.
yep, we have our law seminar coming up this Friday at Mohegan Sun. And then October 21st, we have asbestos. The company, we have a representative going to be explaining everything about asbestos that we need to know. And then after that, November 4th, we'll have exterior finished insulation. We have a guest speaker for them. And then we're Scott's giving Radon and Air December 2nd. So check our site for updates. And thank you for coming tonight.
Thank you.
Thank you.